Good day guys, this is your tutor engineer. Today we are continuing with our series on geometry. We'll be doing analytical geometry lesson today. So let's start. In the diagram below, cycles with centers A and C are drawn. The equation of the cycle with center A is this one. DE is a common tangent to cycles A and C at point B. C is in the second quadrant. The first question is, write down the coordinates of the center of A or cycle A and determine the radius. Okay, let's jump right onto it. For the first question, write 4.1 here. So the coordinates for A, you'll find them from the formula for cycle A. You're just going to flip -2 sign around. You're going to have -2, and then the y coordinate is going to be 6. And then to find the radius, we know that cycle A, we're given that it's passing at point B, which has coordinates -3 and 5. So we're going to use coordinates for B to find the value of the radius. So let's write the formula for cycle A first. As it is equal to r squared. So using point B, right, point B has coordinates -3 and 5. So we'll replace x by the x coordinate and then y by the y coordinate. Squared is equal to r squared, and then remember that one is a squared, and then here is -1 squared plus -1 squared is equal to r squared. 1 plus 1, that means r squared is 2. If we want the radius, we'll say the radius is √2. That's the radius for cycle A. Then we can write the entire formula as x plus 2 plus y minus 6 is equal to r squared, which is 2. So that would be 4.1. And then the following question is, determine the equation of the tangent DE in the form of y is equal to mx plus c. So we already know that DE is passing through point B. Now we need to find more information to calculate the formula for DE. We need to find the gradient actually for DE. The only way to find the gradient at this point is that since we know that point A has coordinates -2 and 6, the rule is the tangent is perpendicular to the radius of the cycle where it makes the contact. So if you can find the gradient for AB, we'll be able to find the gradient for DE since the two lines are perpendicular. So now let's do so. Let's calculate the gradient for AB. It will be y at A minus y at B divided by x at A minus x at B. Y at A is 6, y at B is 5, divided by y at A is -2. Sorry, x at A is -2, x at B is -3. This will become 1 at the numerator. Then the denominator is -2 plus 3, which will become 1 divided by 1, which is just 1. Okay, so the gradient for AB is 1. Let's find the gradient for DE. Since the gradient for DE, since DE is actually parallel to, in fact it's perpendicular to gradient AB, there is a rule when the two lines are perpendicular that their gradients must give you -1. So this is always true here. So we're going to use this information we're going to use this rule rather to calculate the gradient for DE. So we've already worked out the gradient for AB, that is 1, right? So which means the gradient for DE is going to be minus 1. Now that we have the gradient for DE, we can calculate we can write the entire formula as y is equal to minus x plus c. So remember that line DE is passing through point B, which has coordinates minus 3 and 5. So let's work out the value of c. Okay, here we'll replace by point B coordinates y is 5, then x will be minus 3 plus c, and then here you will have 5 is equal to 3 plus c, then 3 will come this side, therefore c is equal to 2. Now we can write the full formula as y is equal to minus x plus 2. I'm sorry, here the value of c is 2. So this will be the final answer for question 4.2. Now let's go to 4.3. Determine the coordinates of c if AB divided by BC is equal to 1 over 3. Remember, AB is a radius for cycle A, which we have already established as root 2. Now let's write this. We're given AB is equal divided by BC is 1 over 3. Okay, so we know that AB is root 2. Then let's find BC. If we cross multiply this, we'll have BC on the left hand side, BC times 1, then the right hand side root 3, so 3 times root 2, then we'll have BC is equal to 3 root 2. So that's the radius for cycle C. Let's write here 3 root 2 between B and C. Now let's make a diagram. In fact, let's start changing colors from here. Choose a red color. Here, let's make a diagram like this to find the coordinates of C. So it will be something perpendicular. So with the gradient for AB, we said it was 45. So that means so the gradient for AB, I'm sorry, it was 1. If the gradient is 1, if your gradient is 1, that means the line is 45, right? So the line of this gradient, if it's 1, that means the angle here is going to be 45 degrees. So that's basically why I'm getting that 45 degrees. So they will also have 45 degrees. Now let's calculate this side and that side. In fact, so let's call this side y, then let's call the horizontal side x. Okay, so we know that let's just wrap this thing off so that you can have some little bit of a space. Okay, we know that cos 45 to find an x is equal to x divided by r. R is 3 times root 2. Cos 45 we can replace by 1 over root 2, or you can just simply use a calculator, but cos 45 is 1 over root 2. Then here you'll have 3 root 2. That means once you simplify this, you can just multiply and solve for x. Basically what you're doing here, you're solving for x. That means x will be the root 2 and root 2 will cancel. X will be 3. So if x is 3, both of these angles are 45. If x is 3, then y will be 3 as well. Now we can find the coordinate of C. So the coordinate of C has the y coordinate of B. So since the y coordinate of the capital letter B is 5, you can just subtract it to 3, the y that you calculated. Then you'll have 2. That's going to be the y coordinate at C, and then A is the x coordinate at C. So to find in A, since you know the x coordinate at B is -3, we'll write here -3. Since A is slightly to the left of B and x is 3, so we'll write -3. We'll write -3 here. For x, remember this is x, then you'll have -6 as the x coordinate for C. So the coordinate of C is -6 and 2. I hope you understood everything that we did today. If you like today's video, please subscribe and stay tuned on the next lesson on geometry. Cheers.